A biologist is investigating the growth of a population of a species of rodents. The biologist proposes this model. N is the number of rodents, T is in weeks after the start of the investigation. So we need to use this model to answer these questions. Find the size of the population at the start of the investigation. Find the size of the population after T is 24 weeks, after the start, to the nearest whole number. Find the number of weeks it will take for the population to reach 400 in the form T equals R log S. And part B, show that the rate of growth is given by this, and the maximum rate of growth occurs after T weeks. Find the value of T. Okay, that's the question then. Let's have a go at it. So part A. First of all, find the size of population at the start. T equals 0. So N, put T as 0 in here. E to the 0 is 1. So 9 times 1 is 9. And 9, e to the 0 is 1. 9 ones are 9, plus 1 is 10. So N is 50. That's part 1. T is equal to 24 then. After 24, what does N equal? T equals 24 now. 500 over the 1 plus 9 e to the minus T over 8. 24 over 8 is 3. So it's minus 3, isn't it? So let's tap that in the calculator. 500 divided by bracket 1 plus 9 times e to the minus 3, wasn't it? Equals 345.28. Three, 4, 5 at nearest whole number. Okay, let me just check that was right. 28, yeah, that's fine. Okay, that was part 1 and part 2. Now part 3, find the number of weeks it will take to reach 400 in this form. So let's put 400 in then and see what we get. And we'll need to move things around. 400 is equal to 500 over 1 plus 9 e to the minus T over 8, wasn't it? So let's move this up to times on this side and move the 400 down to divide on the other. So the 1 plus 9 we've moved up. We've left the 500 as is, and we move the 400 down to be underneath on this side. 5 over 4. Move the 1 over now to take 1, so 9e to the minus T over 8. 5 over 4, move the 1 over take 1, is just 1/4. So that tells us then that e to the minus T over 8 is equal to, move the 9 down, 1 over 36. Take logs, so write this in logarithmic form. In other words, shift the e down to be the base of the logarithm. This number in the air jumps down to ground level, and the e becomes the base of the logarithm, log e of 1 over 36. And I'm going to flip the minus over to this side now. And minus log 36 is minus 1. That can become a power in properties of logs. And this fraction to the minus 1, you just write the fraction the other way up. So that's equal to that. So that tells us what T is then, doesn't it? Move the 8 up to be with it. 8 ln 36. R is equal to 8. S was equal to 36. And these were the integers and the form in which we needed to show it. Okay, that's part 3. Now get dn dt and show it's equal to this. So part B, 1. N was equal to 500, remember? Over 1 plus 9 e to the minus T over 8. It's a function of a function here, isn't it? Okay, because it's 1 over a function of t. So dn dt, let's differentiate, equals something to the minus 1. The minus 1 comes to be with the 500 over something squared, multiplied by the something differentiated. This goes to 0. 9 of these goes to 9 of these differentiated. This is itself a function of a function, so this differentiates e to the something, goes to e to the something, multiplied by that something differentiated. This differentiates to minus 1/8. So that tells us what dn dt is then. Is equal to, now the minuses make a plus, so we got 500 over 1 plus 9 e to the minus t over 8 squared, and then it's 9 over 8 of e to this, isn't it? Okay, that's dn dt. We now need to make some substitutions, don't we? So let's just move these things around. We need this term here squared. So move this up, first of all, and move the n down, so that's equal to the 500 over n. So that's that term there. So we need that and put it in here, and square this will be this squared, so that's the first thing. We also need 9e to the minus t over 8 to put in as well, don't we? So we can just move the 1 across. 500 over n minus 1. So there's the two things we need. So dn dt then is equal to 500 over this squared. This squared is this squared, which is 500 squared over n squared. So the n squared swings up to the top. Multiplied by 9 over 8, well, we'll just put the 1/8 here, and the 9e to the minus t over 8 we can replace by this bracketed term here. So that should work out now to what we wanted. So what does that equal? 500, one of them cancels. 8 times 500 is 4,000. We'll take one of the n's and leave it there. N over 4,000, and take the other n and run it through the bracket. The n's will cancel to leave 500 minus n. So we've got a quadratic in n for dn dt. So that was b part 1, and we've obtained that equation. Here it is here. Now the maximum rate of growth occurs after t weeks. Find t. The maximum rate of growth. Okay. Let me just look back at the question to see what it says. The maximum rate of growth occurs after t weeks. Okay. So we've got a dn dt. So let's just draw this dn dt. We've got a quadratic here. It's minus n squared, isn't it, term? So it's going to be an n-shaped curve. The roots are n equals 0 and n equals 500. And we've got dn dt here. This is our curve for dn dt. We can see here, this is the value of dn dt. Okay, so dn dt is positive here. It has a maximum here, doesn't it? That would be d2n, the gradient of dn dt, d2n by dt squared. Okay, let's see what we get here. No, that's not quite what we want to do, sorry. So what have we got then? We've got dn dt is equal to n over 4,000, 500 minus n. We need to know when n is maximum. Well, we let that equal 0, don't we? So was it when n is maximum? Let's look back at the question. Find the number of weeks that it takes for the population to, and we've done that. The maximum rate of growth. The maximum rate of growth. Find the value of t. So the rate of growth is what we want. When is that maximum? Not n. So I read the question down wrongly. Written it down wrongly, I think. The maximum, oh no, the maximum rate of growth. So when is dn dt maximum? So this is maximum when Well, from the quadratic, and this is a quadratic, there's symmetry, max here, so n would equal 250. Okay, so when n is equal to 250, we need to find the time, don't we? So 250 then. 250 is equal to 500 over 1 plus 9 e to the minus t over 8. This cancels with this to leave 2. Move this up. So the 1 plus 9 e to the minus t over 8 is equal to 2. Move the 1 over. So we get 9 e to the minus t over 8 is equal to 2 minus 1 is 1. E to the minus t over 8 is equal to 1/9 then. And take logs. Minus t over 8 is equal to ln. So move the e down to be the base of 1/9. And then t, let's have a look at this. Move the minus over, ln 9, and move the 8 up, 8 log 9. So what does it want us to round it to here? After t weeks. So let's find out what we get. 8 times ln 9 equals 17.57. So we can say 17 or 18 weeks, can't we? Because this is just nearer 18 than 17, I'd say 18. And that would be to the nearest week. Whole week for this answer here of 18 weeks.